Hello viewers, in today's class we are going to discuss one important problem from Lagrange's mean value theorem, right? And here we have to discuss or verify Lagrange's mean value theorem for this function f of x is equal to 2 sine x plus sine 2x in the indicated interval, which is 0 to pi, right? So let us first quickly see the statement of Lagrange's mean value theorem. Okay, so let us take a function y is equal to f of x, right? And suppose this function is defined in the interval a comma b, or this is the domain of this function y is equal to f of x, right? And now if we have two conditions, right, that is this function satisfies two conditions. The first one is f of x is continuous in the closed interval a comma b, and the second condition is this function is derivable or differentiable, right? That is f dash x exists for this function in the open interval a comma b. Then Lagrange's mean value theorem says that if these two conditions are satisfied for this function, then there must exist some point between a and b, say the point is c, which belongs to this interval a comma b, such that the derivative of this function f of x at this point x is equal to c, that is f prime of c, must be equal to the quotient of fb minus f of a divided by b minus a, right? So this is the statement of mean value theorem, right? So here if this function f of x satisfies these two conditions, it means this function must be continuous and the derivative of this function must exist in this interval. Then there is a point between a and b, say this point is c, right? So at this point x is equal to c, the derivative of the function must be equal to the quotient of fb minus fa divided by b minus a, right? And if we now take this function, then if we compare this interval with a comma b, then we have a is equal to 0 and b is equal to pi, right? So we have here 0 and here we have pi, so we have to find a point c between 0 and pi such that this function holds the mean value theorem, right? So let us start and let us first see this condition, right? And here we see that fx is equal to 2 sine x plus sine 2x. Now it is a combination of two trigonometric functions, right? So sine x is continuous and sine 2x is also continuous, right? So sine x and sine 2x both are continuous in this interval, that is 0 to pi, and fx is a sum of two continuous functions, right? So this is continuous plus this is continuous, right? So we are writing this just for the sake of simplicity. So f of x is a combination of two continuous functions, so it is a continuous function in the interval 0 to pi, right? Now let us take the second condition. Now see, if we differentiate f of x, what we will get? So f prime of x is equal to 2 cos x, because the derivative of sine x is cosine x and the derivative of sine 2x is 2 cos 2x, right? So now we see that this function f of x is obviously derivable in this interval 0 to pi, right? Because f prime of x is 2 cos x plus cos 2x, and for all values of x which lies between 0 to pi in the open interval 0 to pi, f prime of x exists, right? So we see that the conditions for Lagrange's mean value theorem are satisfied by this function f of x, right? So now we move to the next step. So x is there must exist some point c between 0 and pi such that f prime of c is equal to fb minus fa over b minus a. So here if we write f prime of c, then we have fb, b is pi, so we have f pi minus f of 0 divided by pi minus 0, right? And now f prime of c can be calculated from this expression. If we take x is equal to c here, then we have f prime of c is equal to 2 cos c plus 2 cos 2c, right? So now we can substitute this value over here. So we have 2 cos c plus 2 cos 2c is equal to f of pi. Now let us calculate the value of f of pi. So f of pi is 2 sine pi plus sine 2 pi, right? And we know that the value of sine pi is 0. Similarly, sine 2 pi is also 0. So this is 0, right? And moreover, we know from trigonometry that sine of n pi is equal to 0 whenever n belongs to the set of integers, right? And similarly, f of 0 is 2 sine 0 plus sine of 2 times 0. 2 times 0, so here we have 0. So this is 2 times 0 plus 0, that is 0, right? So now f of pi is 0 minus f of 0 is also 0 divided by pi minus 0 is pi, so this is simply 0, right? So now we have 2 cos c plus 2 cos 2c is equal to 0. Let us divide both sides by 2, so we are left with cos c plus cos 2c is equal to 0, right? So now we have to solve this equation for c, right? And we see that this is a trigonometric equation. So for solving this equation, what we will do, we'll write cos 2c is equal to minus cos of c, right? So we'll take this term to the right hand side, so we have minus cos c, right? Okay, so now here we can write minus cos c as cos of pi minus c, right? Because from trigonometry we know that cos of pi minus theta is equal to minus cos of theta, right? And now from this equation we can write c, cos and cos get cancelled. We can write 2c is equal to pi minus c, and this is 2c plus c is equal to pi, and 2c plus c is 3c is equal to pi, so c is equal to pi over 3, that is 60 degrees, right? And we can easily see that this c, which is 60 degree or pi by 3, it lies between 0 and pi, right? So this value belongs to this interval 0 to pi. So this is how we can see that this function is verified or it holds the Lagrange's mean value theorem in this interval that is from 0 to pi.